And welcome to Technology Tap. I'm Professor J. Rod. In this episode, the language of networks, addressing, connections, and communication. Let's tap in. Welcome back to Technology Tap, where we keep tapping into technology. I'm Professor J. Rod, and today we're decoding the language that keeps every network alive, addressing and connectivity. Whenever you're installing a router at home or supporting the hundreds of users in an enterprise, the same fundamentals apply. IP addressing, ports, DHCP, DNS, VPNs, and VLAN. This episode follows the module for the CompTIA core exam, and by the end, you'll see how every packet knows where it's going and how it gets there. Internet connection types, from modems to fiber. Every internet session begins with a modem, the bridge between your network and your internet service provider. DSL, digital subscriber line, runs over regular phone lines. Asymmetric DSL is faster download. Symmetric DSLs keep speed equals for business that upload data consistently. Cable modems. Shared coax cable used by TV networks governed by DOCSIS standard. That's why upgrading to DOCSIS 3.1 can bump you from 300 megabits per second to 1 gig. Fiber to the premise. Pure glass from the provider straight to your home or business, terminating at ONT, optical network terminal. Wireless and cellular. Imagine a rural repair shop too far for cable or fiber. It might use a fixed wireless through a wireless ISP. Or WISP. Satellite, like the Starlink LEO constellation, offer lower latency alternative to geostationary orbit. And on the go, cellular networks have evolved from 3G CDM to 5G with massive MIMO, enabling speeds once reserved for wirelines. Routers and firewalls. Your router makes IP-based forwarding decisions determining which interface each packet uses. Meanwhile, a firewall enforces rules, known as access control lists, filtering traffic by IP, MAC, protocol, or port. Think of it as a bouncer checking IDs before anybody enters the network club. Here's an example. A rule that says allow TCP 443 from any internal web server permits encrypted HTTPS traffic, but blocks everything else. The 4-layer model. The TCP/IP is a suite of protocols with layers. 1. Link layer, frames traveling using MAC address. 2. Internet layer, routing packets via IP address. 3. Transport layer, TCP versus UTP segments. And 4. The application layer, protocols like HTTP and DNS. This TCP/IP 4-layer model is similar to the OSI model. The OSI model, as you know, has 7 layers. The TCP/IP model has only 4 layers. Each layer wraps the data in its own header, like stacking envelopes inside envelopes. IPv4 masking and addressing. An IPv4 address is 32 bits long, 4 octaves, 8 bytes each. 4 times 8 equals 32. So, for example, 192.168.1.25. Each octave, so for example, 192 will be considered an octave, has 8 bits. 168 has 8 bits. 1 has 8 bits. 25 has 8 bits. Where do you get the number from? The number, and I'll have to do a little bit of a deep dive on this. The number depends on how many bits you turned on, which bits you turn on. So there's certain bits, there's the 8 bits are 128, 68, 32, 16, 8, 4, 2, 1. And so 25, you would have 16 on, 8 on, and 1 on. So that's the example. But I'll do a little bit of a deep dive on another episode about IP addressing. It cannot be done. It has to be its own separate topic. The subnet mask device network ID and host ID. Example 255.255.255.0 means the first three octaves identify the network. Public versus private. Private range uses inside lands. The class A is 10.0.0.0. For class B, the range is 172.16.0.0 to 172.31.255.255. For class C is 192.168.0.0. The router performs NAT, or network address translation, mapping private address to public ones. That's how hundreds of devices share one internet IP. Again, this is another topic that's going to have its own segment because it's just too, I can do 23 minutes just on public-private addressing. So that'll be its own separate thing. So example, your phone 192.168.1.50 sends a request. The router translates it to 75.32.18.7 on the internet. The reply returns and is DNAT back to you. Static, dynamic, and APIPA. Static IP, you manually enter it, useful for printers and servers. Usually you want to use static IP for devices that are never going to change, that you don't want the IP never to change. So, your printers, your servers, your routers, maybe a managed switch, right? Those are devices that you never want to change. So it's fine. DHCP automates address assignments through DORA. Discover, offer, request, acknowledge. These are for like your workstations, right? Things that you don't care if the IP address changes. Pretty much your workstations, you don't really care if the IP changes. You don't need to hard code your workstations. And APIPA is when the address starts with 169.254, appears when DHCP fails, Windows way to stay local when disconnected. IPv6, which is going to be the new standard of internet addressing. When is that going to happen? Who knows? I've been hearing about IPv6 for the last 10 to 15 years. Yeah, I don't know when it's coming. Coming soon, it's like forever. So what's the biggest obstacle? I'm pretty sure it's money. And why? Why at this point, if everything's working, why change it? And then in order to change it, it's gonna cost money. It's gonna cost time. You got to get these techs to make all these changes. That's gonna cost money. But anyway, IPv6 uses 128 bits, hexadecimal notation, and colons. So an IP address can be, let's say, 2001 colon 0DB8 colon 8583 colon 000 colon 000 colon 8A2E colon 0370 colon 7334. Dual stacking lets IPv4 and IPv6 run side by side. Organizations adopt IPv6 for its nearly limitless address space. I don't know anyone that is actually using it, but again, it's coming soon. You have your protocols and ports. TCP and UDP uses ports from 0 to 65,335 to differentiate service. TCP is connection-oriented, which is reliable. UDP is connectionless, faster, but no guarantees. UDP is like Netflix, YouTube, right? A lot of data going back, send me the data, right? TCP is like email, logging into a website, right? So some well-known ports that we have out there that, you may need to learn. FTP, File Transfer Protocols, uses port 2021 and is TCP based. SSH, port number 22, TCP based. DNS 53, it's UDP and TCP based. HTTP is 80 port 80, and it's TCP based. HTTPS, port number is 443 and is TCP based. DHCP, port number 67 and 68 and is UDP based. And RDP, remote desktop, is 3389, TCP based. When you're visiting a website using HTTPS, your browser initiates a three-way handshake: sync, sync-ACK, and ACK to establish a reliable connection. Sync means synchronization, and ACK means acknowledgement. So it's synchronization, acknowledgement, and then acknowledgement. A real-world example is a game streaming platform may use UDP for real-time videos because dropping a few frames is better than delaying the stream. Just like Netflix, right? Dropping a few frames in Netflix is better than delaying the film. So, and they use UDP. Network configuration concepts, DHCP functions. A DHCP server manages scope, leases, and reservations. If you reserve a MAC address, that device always gets the same IP. Perfect for printers or security cameras. DNS, the phone book of the internet. The domain name system translates names into IPs. When you type, www.google.com, right, it resolves to something like 8.8.8.8. A record type should know A through quadruple A is IPv4, IPv6. CNAME is your alias. MX is always for mail server. And that's a clue for the CompTIA test, right? If you see a question and the question that they ask you has the word MX in it, just look for mail server or email. That's usually what the answer is. And TXT or text verification or SPF data. Example, DNS lookup follows a chain, root server, right? Then the top level domain, and then the authoritative server, and then your answer. VLANs and VPNs. VLAN or virtual LAN segment a switch into isolated broadcast domains. For instance, separating finance traffic from students in a campus network. And then your virtual private network creates an encrypted tunnel over public Wi-Fi. Example, when you connect your college VPN, all traffic to internal servers is secure, even if you're in a coffee shop. Again, some of this stuff, we would have to expand on it. It's just, to do these short snippets that I'm trying to do, especially with the questions at the end and the allotted 23 minutes, 24-minute time that I want to get to. It only gives us time for these snippets. But I will do like a deep dive into DHCP, DNS, VLANs. That deserves, public private address. All that stuff deserves huge deep dives, separate podcasts on its own, separate episodes. I'm following the like what CertMaster gives you, which honestly doesn't really give you a lot as far as the PowerPoints is concerned. And that's what I'm using just for quick snippets. But to be fair, I have to, if I'm going to, be a good instructor or a good teacher, I have to give you, the full definition of what DHCP does. And I have a whole thing, if you take my class and I've gone over DHCP, you know how I do it. I do a whole scenario and stuff, but it deserves its own episode. A couple of these things, now that we're getting into the meat of A+, it deserves its own episode. Some of these stuff, it's just too big to cover in snippets. So, all right, let's do the questions. All right, so if you're new to this, the way I do it is I ask the question, I read the choices, and then I do it again. I give you 5 seconds, and you try to guess if the answer is right. Question 1. Which internet connection typically uses an optical network terminal at the customer's presence? A, DSL, B, cable, C, fiber to the premise, or D, satellite? Again, which internet connection type typically uses the optical network terminal at the customer premise? A, DSL, B, cable, C, fiber to the premise, or D, satellite? I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is C, of course, fiber to the premise. Connections terminate at an ONT that converts optical signals into internet for use inside the building. And ironically enough, ladies and gentlemen, if you took my classes years back, I would always say there was, there's no way they would put fiber in your house. But now they do. They actually do put fiber in your house, which I find amazing that they do that. Because fiber, if you know anything about fiber, is very, very delicate. I have a Verizon 2 gig, and there's actually a fiber cable inside my house, which I never thought they would do. I would never thought they would do, but it's there, so I just got to be careful not to break it. All right, question 2, addressing. Which IPv4 address range is reserved for automatic private IP addressing, or APIPA? A, 10.0.0.0/8, B, 169.254.0.0/16, C, 172.16.0.0/12, or D, 192.168.0.0/16. I'll read it again. Which IPv4 address range is reserved for automatic private IP addressing, or APIPA? A, 10.0.0.0/8, B, 169.254.0.0/16, C, 172.16.0.0/12, or D, 192.168.0.0/16. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is B, 169.254.0.0/16. Windows assigns a APIPA address in the 169.254.0.0 to 169.254.255.255 range when no DHCP server is available. See, this is what I mean. Like, that is something that I need to explain more, right? So maybe the next episode of A+, I will go into a whole deep dive of what DHCP is, how it works, fully explain it, break it down. I think I do a really good job of breaking it down for my students for DHCP, using a scenario that everybody's familiar with. And then that way you really understand how, things work, right? Because we're getting into the granular level of things, and you really need to know how these things work, especially if you're going to take the A+ class. So, and I'm going to do a lot more deep dives on the A+. All right, protocols and ports. A network administrator wants to secure remote logins by encrypting traffic. Which protocol and port should they use? A, Telnet, port number 23. B, SSH, port number 22. C, HTTP, port number 80. D, FTP, port number 21. Again, I'll read it again. A network administrator wants to secure remote logins by encrypting traffic. Which protocols and port should they use? A, Telnet /23 or port number 23, SSH port number 22, HTTP port number 80, or D, FTP port number 21. So here's how you would tackle this question. And this is part of the CompTIA way, right? If you look at the question, if you listen to the question, because you can't look at it. If you listen to the question, you will see that it says a network administrator wants to secure. Just that word secure, that's the clue in the question, secure. So out of all of these, which one could you eliminate right away? Well, HTTP is not secure, so that's out, right? Telnet, if you know anything about Telnet, that's not secure. That's out, right? And then you're left with SSH and FTP, and then wants to secure remote logins. The answer is B, SSH, right? SSH encrypts remote terminal sessions, unlike Telnet, which sends data in plain text. So there's also about 20, 22 of these ports that you need to know for the exam. I will also do a deep dive on that. It's important that you know these. And once you know them, it's scaffolds, right? So this is the good thing about CompTIA. And this is the good thing about taking a CompTIA exam at A+, at the A+ level, and not skipping to Security Plus right away, right? There's some people who right away, they don't do anything. They don't never worked in PC before. Maybe they fixed their friend's PC, right? They have one guy, but they've never really worked in IT. So they want to jump all the way to security, and that test is really hard. I mean, there's people who've done it, and I've known 2 people who have done it, but both former students. But most people can't. I mean, you really got to be dedicated if you want to take a security Plus course or study on your own. I know one young lady who studied on her own and she passed, and then one took a class with me and he passed. But it's not an easy exam, and to just try to jump in the line, it's kind of difficult. But if you start at A1, A plus, it scaffolds. So you go to Network Plus, like 50% of Network Plus is in A plus, and like 30% of Security Plus is in A plus. So you learn the foundation, and it's better to start at A plus. I don't know why people want to jump the line, but that's them. All right, last question, network configuration. What is the primary purpose of virtual LAN or VLAN on a managed switch? A, to provide wireless coverage in large area. B, to segment network traffic for performance and security. C, to encrypt tunnels over the internet. Or D, to assign dynamic IP address to clients. I'll read it again. What is the primary purpose of a virtual LAN or VLAN on a managed switch? A, to provide wireless coverage in large areas. B, to segment network traffic for performance and security. C, to create encrypted tunnels over the internet. Or D, to assign dynamic IP address to clients. Now, before you tackle this question, if you listen to it, there's a couple of clues here. One is managed switch, right? So anything that has to do with IP addresses, it's out, because switch does not manage IP address. So D is out, to assign dynamic IP address to clients, that's out, right? So you're left with to provide wireless coverage in large areas, to segment network traffic for performance and security, and to encrypt network tunnels over the internet. Nothing to do with the internet. A switch does not do anything with the internet. C is out. So you're left with A and B, and the answer is B. VLANs divide a switch into multiple logical networks, isolating traffic and reducing broadcast domain for better performance and security. That's how you tackle A plus exam, just like the way I did it. Just look at the question. Not every question is going to have a clue, because a lot of them is going to say, hey, what's the port number for Telnet, right? So that there's no clue in that. Either you know it or you don't know it. But some have clues. And you look at the clues from just reading the clue, reading the question. You got to dissect it, right? That's what I call it. You got to dissect the question. But you only got a minute to do it. You don't have a lot of time. You got to average a minute a question. So I always tell my students, go through the exam the first time, answer the questions that you can answer, right? If you answer the questions that you think you can get it right, answer those and then go back and then answer the rest. And then take your time, because you can answer a question that 10, 15 seconds. So then that will help you 100%. All right, let's wrap this up, guys. From DSL to DNS, from IPv6 to VPNs, you now understand how addressing keeps the internet organized. The CompTIA test doesn't just test your memory, it tests how you think through connectivity problems. I'm Professor J-Rod, and I just want to remind you, stay curious, stay secure, and always keep tapping into technology. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J-Rod, that's J-R-O-D, or you can email me at ProfessorJrod, J-R-O-D, @gmail.com.